Okay, students, today let us understand the convolution of pulse signals. First, let us see what exactly is a pulse and write the equation for getting the pulses. First of all, pulse is a signal which is present over a range. For example, now in case of discrete time pulse, how I will draw discrete time pulse. See, the discrete time pulse I am just drawing like this. Say it is present from 0, 1, 2, 3. This is a discrete pulse. It can have any magnitude. Generally, I am just giving a magnitude 1. It can have any other magnitude also. Now, how exactly to write the equation for this? This is x of n. Now, how exactly to write the equation for this x of n? X of n, you have to see the starting point. It is 0. That means it is u of n. Minus, where exactly it ends? 3. You have to write it as u of n minus 4. Please verify. Please check that. Here it is 3. Here it is 4. That's how you can write the pulse signal equation. Pulse signal equation in case of discrete time. Now, suppose I gave another example where you want to derive x of n, which is of this kind. X of n, which is present from, say, (0, 1, 2, minus 1, minus 2). It is present like this. Now I have to, magnitude is 1. I have to write the equation for this x of n. How I will write? X of n, starting point you see, it is at minus 2, hence u of n plus 2. U of n plus 2. Minus, where it is ending? It is ending at 2. It becomes u of n minus 3. U of n minus 3. This is how you can write the equation for discrete pulses. Okay, please, this is our ending point. Again, you please need see this. This is 2. I am writing it as 3. This is discrete time pulse. The same thing, same concept if I tell in continuous time pulse, you have to be very careful. How to write continuous time pulses? For example, now in case of continuous time, it becomes x of t, isn't it? It becomes x of t. Now the pulse which is given is starting 0, ending at 3. This is a pulse with magnitude 1. Now how exactly to write this x of t? X of t is equal to, please check, it is u of t minus u of t minus 3. Here it is u of n minus 4. Here it is u of t minus 3. Similarly, if I gave a pulse like this here, you want to derive out from minus 2 to plus 2 x of t. If you want to derive out, then how exactly to write this x of t? Starting point is minus 2, u of t plus 2 minus ending point is u of t minus 2. This is how you can write the equation for pulses. Now, this is the first step. In case of convolution of pulse signals, you should know how exactly to write the equation for pulses, and after that you can convolute the signals. How exactly will be the problem? For example, given two signals, say 0, 1, 2, 3. This is x of n and this is h of n. 0, 1 and 2. Obtain y of n by convoluting x of n with h of n. Now you see this x of n is a pulse. Similarly h of n is a pulse. I have to convolute these two. I need the equation so as to get the convolution of x of n and h of n. Hence first step is to write the signal equation x of n and h of n. That's why you need this or you need this in the case of continuous time. And hence you should know how exactly to write the equation for x of n and h of n in terms of unit step. Okay, I hope you understood this. Let us go ahead with the next so as to convolute two signals. Okay, let us consider x of n and h of n, which are given as pulses as I shown you. First, let me write x of n. I want to convolute these two signals. Find and plot y of n, which is x of n convoluted with h of n. Okay. Now first x of n is equal to, you have to write the equation. Obviously you know that it is u of n minus u of n minus 4, because 3 is there, that's why minus u of n minus 4. Now h of n is equal to u of n minus 2 is there here, u of n minus 3. Now I have to convolute these two. Y of n, which is x of n, u of n minus 4, convoluted with u of n minus u of n minus 3. U of n minus 3. Now take this inside. U of n convoluted with u of n minus u of n convoluted with u of n minus 4 minus, I am just bringing this here, u of n convoluted with u of n minus 3 last, plus u of n minus 3 convoluted with u of n minus 4. Please note that when you are multiplying 2, no, I am writing smaller one first. You just try to convey that, follow that convention. See, here I am multiplying u of n minus 3 with u of n, suppose u of n minus 3 and u of n. What I am doing is u of n I am writing first, so that it becomes easy for you to write the equation. Now I have to apply the convolution formula. How exactly to apply the convolution formula? While you are applying convolution formula, you know that it is summation k is equal to minus infinity to infinity. This is first signal, this is second signal. First signal, instead of n you are using k. U of k, u of second signal is n minus k. Similarly, minus summation k is equal to minus infinity to infinity, u of k, here instead of n it is n minus k, isn't it? Hence it becomes u of n minus k minus 4. See that instead of n here I am substituting n minus k, hence it becomes u of n minus k minus 4 minus summation k is equal to minus infinity to infinity, u of k, n minus 3 is there, no second equation, I am just using u of n minus k minus 3 plus the last one plus summation k is equal to minus infinity to infinity. First is u of n minus 3, instead of n k, u of k minus 3 multiplied by u of n minus 4 is there, u of n minus k minus 4, n minus k minus 4. Now here convolution was there between two signals. I substituted with its summation formula. Now you have to apply the logic where the signals will start. Now u of k starting point is 0, hence there is no meaning for me to start the integration from minus infinity. What I am doing is k is equal to 0. What about this u of n minus k? U of n minus k means it ends at n. Hence k is equal to 0 to n 1 minus. Next equation is u of k. Starting point is k is equal to 0. What is the ending point? N minus k minus 4. Please note that variable is k, hence it ends at u of n minus 4. Summation of 1 minus k is equal to starting point 0. K is equal to 0. Ending point is n minus 3. Now plus summation of 1, okay, plus summation k is equal to starting point u of k minus 3 is there. Starting point k is equal to 3, ending point is n minus 4. Summation of 1. Yes, I got 4 terms here. Now what you have to do is you have to identify which terms comes first in the output and all. This is the output. Output consists of 4 parts. Output consists of 4 parts. This is the first part, second, third, fourth, like this. We need to identify which part comes at what instant. I have to identify. Okay. Let me see that now. First, see that k is equal to 0 to n. This term or the first term, whatever is there, no, that is present everywhere for n greater than 0. What about the second term? This term comes into picture at instant n equal to 4, not before that. This comes at n equal to 4. What about this term? This comes into picture n equal to 3. When n becomes equal to 3, then only the term comes into picture. What about this? N equal to 7. Why? Because the starting point is 3. Hence you shift it to up and becomes 7. That's how. What about this? N greater than 0. This is present everywhere. N greater than 0. Now to start with, you have to identify the ranges of y of n. Okay. Now let me determine output y of n. There are ranges now. Starting n for greater than 0, less than 3, and greater than 0, only the first term will be there. Hence y of n becomes equal to summation k is equal to 0 to n summation of 1. You know that this equation gives you n plus 1. Okay, n plus 1. Whatever n is there, no, plus 1 here. Hence y of n becomes equal to n plus 1 for n greater than or equal to 0, less than or equal to 3. Less than 3. Not equal, less than 3. At 3, what happens? At t3, these terms get added. This second term get added. Hence y of, I mean to say here, n equal to 3. This term get added. Y of n becomes equal to summation k is equal to 0 to n1 minus summation k is equal to 0 to n minus 3 1. This gives you equation, already you know that this is n plus 1 minus n minus 3 is there, no? That gives you n minus 3 plus 1. That means n minus 2. What is my answer? My answer become n plus 1 minus n plus 2. Hence it is 3. Y of n is equal to 3. Y of n is equal to 3. Now what about this term? This term is present for n greater than or equal to 3, less than 4. Correct? y of n is equal to 3 for n greater than or equal to 3 less than 4. At 4 what happens? At 4 this term adds. At 4 this term adds, get added. Hence for n greater than 4, greater than or equal to 4, less than 7, less than 7, that means till 6, y of n output becomes equal to summation k is equal to 0 to n1 minus this term second time which I have added, or the previous equation, k is equal to 0 to n minus 3 1 minus, now I am adding this term, summation k is equal to 0 to n minus 4 1. Okay, now because of these two already you know the answer, that is 3. I am writing it directly. Minus. What about this? N minus 4 is there. 0 to n minus 4 summation 1. That means it becomes n minus 4 plus 1, n minus 3. Hence my answer becomes 6 minus n. Correct? 6 minus n. Y of n is equal to 6 minus n for n greater than or equal to 4 less than 7. Now for n greater than or equal to 7, n greater than or equal to 7, what happens? The last term also get added, the fourth term also get added. That means at n equal to 7 this term also get added. Hence y of n becomes equal to all the previous answers, or I will write this complete equation, k is equal to 0 to n1 minus k is equal to 0 to n minus 3 1 minus k is equal to 0 to n minus 4 1 last, plus k is equal to 3 to n minus 4 1. Now this becomes equal to, already these three terms added in the previous step only, the answer is 6 minus n, correct? 6 minus n plus what is the answer? K can be shifted up so that it becomes n minus 7. N minus 7 means the answer becomes, instead of this you can take this as summation k is equal to 0 to n minus 7 1. Okay, hence answer becomes n minus 7 plus 1, that means n minus 6. Hence cancels out, give me answer 0. That meaning here is y of n is equal to 0 for n greater than or equal to 7. I'm just writing all the answers now. All the answers. Y of n is equal to n plus 1. From where to where? N greater than or equal to 0, less than 3, is equal to 3 is equal to 3 for n greater than or equal to 3 greater than or equal to 3 less than 4, is equal to the third answer, is equal to 6 minus n. 6 minus n for n greater than or equal to 4 less than 7, is equal to 0 for n greater than or equal to 7. This is my complete answer. Okay. Now I have to plot this graph actually. Let me plot this graph so that you will understand what exactly is the result of this complete work. Okay, let me plot in the next board. Okay, if you have seen this, these are the equation. Let me see now. I have to plot this, correct? I have to plot this graph. Output y of n. Okay. here it is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 marking I have made. Now 0 to 3 or 0, 1, 2. At 3 this becomes 3. Now 0, 1, 2. What is the equation? N plus 1. At 0, 0 plus 1. That means the answer becomes 1. Now at 1, instant 1, it becomes 1 plus 1, 2. At 2, answer becomes 2 plus 1. That means 3. This is 1, 2, 3. 3. At 3, the answer becomes 3. At 4, you see, it becomes 6 minus n. N is 4 now. 6 minus 4, 2. At 5, 6 minus 5, 1. At 6, it becomes 6 minus 6, it is 0. 7 onwards, anyway it is 0. Anyway it is 0. Now this is how you can identify the output and plot it. There is another way to do this also. Let me do in the next class. Actually it is a graphical method. Same problem I will try to solve it graphically. Okay, and let us see how exactly you will respond for that graphical method. But this is very conventional, and the way in which it is solved is nothing is missed as such, whereas in the graphical way you should understand how exactly the results come, what is the overlapping points and all those. But this goes in a very conventional way, nothing is missed. If you understood the technique, it is very easy for you to give the output. Okay, I will just give one assignment. That assignment is this. I will write that assignment here only. That assignment is find the output y of n for given x of n and h of n. Okay, those things are, say this is x of n, x of n is 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is x of n. Similarly, h of n zero, 1, 2, 3. Okay, this is h of n. You have to convolute these two so as to obtain y of n. Obtain and plot y of n which is equal to x of n and convolute it with h of n. Obtain this. If any doubts are there, you can reach me. I hope if any doubts are there, you can come to contact classes also. Thank you.